Today we are going to discuss the chapter triangles, which is chapter 6 of class 10th. What we'll do in this chapter is first we'll go through the concept which is given in your text, and we will try to create some examples around it so that you can understand this concept better. And finally we will deal with some of the exercises which are given towards the end of the concept. So let's review the chapter first. So yeah, let's go ahead with the first section. Here in this section, what the book is talking about is congruency, which is something which we had discussed in last class as well, which is of standard 9. So that if two figures are having same shape and same size, then they are called to be congruent. So let's understand how this will look like an example. So we'll create something more like this. We'll create some examples around it. Let's see. We come down here. We take a shape. Let's say a triangular shape. We can take from here. Yeah. Let's take a shape here. Now let's make it a little bigger. Now if say I take a copy of it. And then I just move this over here. What we can see here is that this shape and this shape both are same and their size is also same. So what I mean is, like, if I put it on top of it, I can see that both of them are equal because yes, I have taken a copy of it, right? So yes, these two figures are congruent because they are having the same shape and same size. Similarly, you can also have more of a rectangle, right? Make it a little bigger again, and then again take a copy of it. So yes, so this is again gonna be congruent shape. And we have also studied that if two circles are having same radius, then they are also said to be congruent. So again you can see here that these two are congruent shapes, and then if I try to superimpose this on it, these two will be exactly same, of course, because they are exact replica of each other. So what's congruency? Congruent, two figures are congruent when they have same shape and same size, right? Now they have taken this concept further and they have talked about similarity of figures. What is similarity of figures? So similarity is when your shape is same but the size are not same. So what do we mean by it? For example, let's say I take this triangle and I reduce the scale of it by some measure. So I make it a little smaller like this. What I've done is from every side, every angle, it is reduced to same ratio. So when you put it on top of it, when you bring it over here, you can see that these sides are basically parallel to each other. These sides are parallel to each other. These sides are parallel to each other. Means that the angles are equal, and basically they are of not same size. They are of different sizes. Similarly, you can make it a little smaller like this, and then again try to bring it inside and see that yes, again these two figures are similar because they are same shape but not same size. So similarity is same shape but not same size. Alright, so this is what the similarity of figure is. Let's go back to the chapter and see again what they have talked about. Yes, now let's move further down, and they have shown these figures. They have tried putting it inside so that these two are similar figures. Then there is something they are talking about, which is very obvious, that two congruent figures are similar, but similar figures need not be congruent. You can understand that congruent figures are having same shape and same size, but the necessary condition in similarity is that they have to be just having the same shape, but the size need not be same, right? So because of this, all the similar figures need not be congruent, but all congruent figures will be similar. Here again they have shown some pictures here, and they have tried showing that the scale is reduced the way we had reduced the scale when we were drawing in our examples. And then finally over here they have talked about two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are also in the same ratio or proportion, which we have already seen in case of triangles as well as in case of quadrilaterals. Alright, there are some activities which you can do and then understand more about it. Then this is the final concept. They have talked about that two polygons of the same number of sides are similar if all the corresponding angles are equal and all the corresponding sides are in the same ratio. So you can understand in our example what we had done, that again these two are having three sides, right? Three sides each, and then their angles are equal. Then the angles are equal because these sides are looking parallel to each other. So this angle is equal to this angle, and similarly this angle is equal to this angle, and this angle is equal to this angle, right? Similarly here this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this, and this equals to this, right? So this is about congruency and similarity of figures. Now we can go to the examples and then see whether we can solve these examples or not. So let's see. These are some of the exercises given. The first one is saying all circles are congruent or similar. See, all circles are congruent and similar. So you can see this is also a circle, this is also a circle, right? This is also a circle. Now you can see this circle is smaller in size, right? This circle is smaller in size, so they could be similar but need not be congruent, as you can see. Similarly, all squares, same argument over here as well, they can be similar, need not be congruent. All equilateral triangles should be similar because their angles are same, right? And then two polygons of the same number of sides are similar if their corresponding angles are equal. That's what we had read in the last section, and their corresponding sides are proportional. This is what we had read. Give two different examples of pair of similar and dissimilar figures which you can think of. Similar figures could be more like triangles, two triangles, again non-similar triangle and quadrilateral. And then the last example here is you can see the angle here is 90 degree and this angle is looking like not 90 degree, though the sides are in the ratio 1:2 because this is 1.5 and this is 3, right? So these this is looking in ratio, but this angle is not looking like 90, not looking like 90 degrees. So these quadrilaterals are not similar. So yes, this is all in the first exercise. Now we will look at the examples and understand the next exercise in the next lecture. Thank you so much.